Welcome to Module 11 on Applications of Linear Equations. Right now, pause the video, find a writing utensil and a piece of paper. A spiral-bound notebook is perfect for what you'll need for this course. If you need help getting a notebook, let your teacher know today. Note-taking will be important so that you have access to what you're learning without having to rewatch the videos. Plus, you can use your notes on the quizzes. Today we're going to be talking about applications of linear equations. So essentially we're going to be choosing stories that can be represented by given equations. We're going to be writing our own equations in the form ax plus b equals c. We're going to be choosing stories that can be represented by two-step equations and solving a one-step word problem using the formula distance equals rate times time. So we're going to start by choosing a story based on a one-step equation. Don't forget that you should have your code words still listed from Module 10 to help you. So one of the things I want you to notice about this is it says select all of the stories that can be represented by the equation. So there might be more than one for each one. So for A, what we've got is 10 times some variable equals 70. So I'm just going to go through this step by step. Anna's math test has X problems. She solved 10 of them. There are 70 problems left for Anne to solve. Well, if we're looking for something that's left, that should be a subtraction problem, which we don't have, so we're not going to choose this one. Anne's math test has two parts. One part is worth X points, the other part is worth 10 points. The test is worth 70 points. Well, if I'm putting two parts together to get a total, that's addition, so I would not be using that one. Anne's math test covers X chapters. Each chapter has 70 questions on the test. The test has 10 questions. No, because we want the total to be equal to 70, not equal to 10, and so it would not be that one. Anne's math test has 10 problems. Each problem is worth X points. Her math test is worth 70 points. Yes, that is the one I would choose for that one. All right, let's use the same process for B. Scott is X years old. Anne is 10 years older than Scott. Yeah, 10 years older would be add, so I think we're okay so far. Anne is 100 years old. Yes, I think we could choose that one. Anne is X years old. Scott is 10 years younger than Anne. Scott is 100 years old. No, we don't want to choose that one. Younger than would be a subtraction problem. Anne is X years old. In 10 more years, she will be 100 years old. Yes, because more would be add. Scott is X years old, and 10 years ago he was 100 years old. No, 10 years ago would be subtract, so we don't want to choose that one. So it would be the first one and the second one. All right, your job now is to pause the video and try these on your own. All right, you should have worked your way through each one. We should notice that we have a multiplication problem here and a total of 20. Shen finished reading his book in 4 days. Each day he read X pages. His book has 20 pages. Yeah, because he's reading X pages every day. That's a multiplication problem, so I would choose that one for sure. Shen finished reading his book in X days. Each day he read 4 pages. His book has 20 pages. Yes, this is the same setup as the original. Both 4 and X should be multiplied. They've just switched which one is the X variable for this one. A book is X pages long. Shen read 4 pages. He has 20 pages remaining. No, remaining would be a subtraction problem. A book has 2 parts. One part is X pages long. The other part is 4 pages long. The book has 20 pages. No, if we have 2 parts, that would be an addition problem. So you should have chosen the first 2 there. For part B, Ivana had X tickets and her friend gave her 8 more tickets. Ivana now has 56 tickets. No, 8 more tickets would be an addition problem. This is a subtraction problem. A football game ticket costs $8. The cost for X tickets is $56. Now we're buying multiple tickets here, so that should have been a multiplication problem. Ivana had X tickets, then she gave her friend 8 tickets. Ivana now has 56. Yes, it's got a total of 56. She gave means took away, should have been subtraction, so you should have chose that one. Ivana had $8, then she bought a football game ticket for X dollars. Ivana now has $56. This would not be accurate because this would want to start with $8 and then she would need to buy a ticket for a total of 56. So it should be just that one. Now, writing an equation to solve a problem. Melissa is saving money to buy a bike. She has $63 and is going to save an additional $9 each week. The bike costs a total of $198. It says write an equation that could be used to answer the question above. First choose the appropriate form, then fill in the blanks with the numbers 63, 9, and 198. Let W represent the number of weeks. So essentially, we need to decide, is this an addition or subtraction problem? First of all, it should be an addition problem. She's going to save $9 each week, and because we've got each next to the 9, that means the 9 needs to go with the W. She already had $63. That doesn't need a variable with it. It's not $63 every week. It's a one-time amount of $63. And then the total is 198. To do B, we're going to subtract 63 from each side. So I get 9W equals 75. We're dividing 75 by 9. Let me double check my math there. 198 minus 63 using my calculator. Sorry, that should have been 135. And divide both sides by 9. And you get the number of weeks should be 15. You pause the video and try this one on your own. All right. Kayla bought some books. She spent a total of $71 after a discount of $5 off of her total purchase. Well, that's telling you we want the subtraction problem for this. She spent a total of $71, so 71 should be your total there. Each book costs $4, and she got a discount of $5 off of her purchase. So this should have been 4b minus 5 equals 71. And then to get the number of books, we're going to solve that. So I'm going to go over here to the side. I'm going to add 5 to each side, so 4b equals 76. We're going to divide both sides by 4. The 4's cancel out. 76 divided by 4 becomes 19. So she bought 19 books to spend a total of $71. Now let's write an equation using the formula D equals RT. So D equals RT is a formula that you're going to see frequently, and you're going to want to know what those variables stand for. So I want you to write a new topic, write an equation using the formula D equals RT, and I want you to write down what your variables stand for. D equals distance, R equals rate, T equals time. This can be used to solve many word problems about speed or how long it's going to take to do something, especially when you have a distance involved. So we've got a construction crew that has just built a new road. They built the road at a rate of 3 kilometers per week. So I know that right now the formula looks like this because I know the rate is 3. They built 93.75 kilometers of road. Well, that's our distance, not our time. So that's 93.75 equals 3t. I'm going to divide both sides by 3. And so it should have taken 18.75 weeks to build the road. You pause the video and try this one on your own. All right, you should have written down the formula distance equals rate times time. The distance is 62.5 because it says 62.5 kilometers. The rate we do not know this time. Oops, sorry. The rate we do not know this time, but we do know the time is 5 hours. So we're going to divide both sides by 5. 62.5 divided by 5 becomes 12.5. And that should be 12.5. So I'm sorry, that should be your R here. That should be 12.5 kilometers per hour. You're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 11. Don't forget to complete your Module 11 practice problems by selecting Continue My Path from the home screen. Don't forget you can click on Explanation if you need some extra help while you're working in ALEKS, and when you're all done, you're going to want to take Quiz 11 to match up with Module 11. Have a great day.